a robot-guided laser making aircraft paint removal more efficient, and an advanced software system protecting fighter jet crews. We highlight two cutting-edge SWRI technologies, recipients of 2020 R&D 100 awards. That's next on this episode of Technology Today. We live with technology, science, engineering, and the results of innovative research every day. Now, let's understand it better. You're listening to the Technology Today podcast presented by Southwest Research Institute. Hello and welcome to Technology Today. I'm Lisa Benya. The prestigious R&D 100 awards presented by R&D World Magazine are known as the Oscars of Innovation. The awards have recognized the top 100 revolutionary technologies every year since 1963. SWRI won two R&D 100 awards this year, bringing our total to 47 since 1971. Today, we're learning about our 2020 winners. Engineer Finley Hicks is here to tell us about SPARTA, the System Performance and Real-Time Analysis Software System, a measurement and analysis tool protecting fighter jet crews. He'll tell us how it works coming up. But first, the laser coating removal robot for aircraft, an environmentally friendly, smart technology, making the tough task of removing paint and coatings from aircraft safer, faster, more cost-effective, and efficient. SWRI engineer and director Paul Evans, who is part of the LCR Robot development team, joins us now. Congratulations on the award, and thanks for joining us, Paul.
Thanks, it's great to be here.
So, Paul, the laser coating removal robot is really a dynamic technology, and it's changing how paint is removed from all types of aircraft. So this no longer has to be done manually. Tell us more about the laser coating removal robot and its capabilities.
Sure. So the laser coating removal robot is really what we call a mobile manipulator. So what does that mean? It means it's a robot arm on a mobile platform. But what's unique about this robot is really its size, considering that it has to reach all around an aircraft. We actually have 4 different sizes for this robot so that it can operate on the full range of aircraft types, from small airplanes to what you would view as cargo size aircraft. The process is focused on coating removal, so removing paint from aircraft through what we call laser ablation. And we can remove a full range of coating types, colors, and we can do that efficiently and intelligently through a process where we monitor precisely removing layers of coatings step by step. And the solution is fast and it's more environmentally friendly than traditional processes.
So can you tell us a little bit more about the CO2 laser that's really, I guess, is it considered the powerhouse of this system? How does it work?
Sure. So the CO2 laser is certainly one of the key pieces of the technology. What it does is enables a wide range of coatings to be removed. There's other laser types that are better matches for a narrow range of materials, colors, so to speak. Whereas the CO2 is a match for a much broader range of color types. So we can remove white paint, clear coats, really most any aircraft coating that you could imagine that's on the market. The other piece to this that's unique is really the process control. So if you will, we use vision system or eyes for the robot to be able to watch closely and see what's actually happening where the laser meets the paint or the coating. And we can watch that and use computer vision and algorithms to determine if we need to do things like change the power level of the laser or change the speed at which the robot's operating. And by that, we can systematically remove the coatings layer by layer.
Why do aircraft operators need to remove paint and coatings? Is this just general maintenance, or is there more to it than that? How is this technology fulfilling a need in the aircraft industry?
Sure, there's a range of reasons why coatings are removed. Most of it is related to maintenance and repair and inspection. So there is, depending on the aircraft type and the coating, there's typically a schedule by which an airplane is going to get depainted. And some of it has to do with weight savings over time as well. So if an aircraft gets coated many times over a period, you would want to remove some of the weight for efficiency, fuel efficiency. Sometimes people are removing paint for doing things like corrosion inspection. Sometimes it might be just a change in the paint scheme for an aircraft. So there's a range of reasons why aircraft get depainted.
So, how have paint or coatings on airplanes traditionally been removed?
So the most dominant traditional methods have been chemicals, sanding, dry media blast is another one where it's essentially like sandblasting, but you're shooting out like plastic pellets instead of sand. And it requires people to be in suits, protected from the process. Some of it is highly repetitive. And so there are opportunities for injury as well as just generally the conditions of being, if you will, suited up and protected from the process. So the idea behind the robot is to have those operators move from a highly manual operation and into a, if you will, an air-conditioned environment where they can monitor a robot and its progress and be able to assist the robot in the process and in getting the job done.
And can you elaborate a little more on the software used to operate the robot?
Sure. So there is a range of software tools that we use on the robot itself. One of them is the process monitoring solution. And in that case, we do train, if you will, the robot for what it needs to see to efficiently and properly remove the paint from the aircraft. So we're looking for transitions and different signatures, if you will, of the transition process between one layer to another, so that you could, if you wanted, just remove a top coat and leave a primer, or remove the primer and go all the way down to if it's a base composite or aluminum. That's important from the standpoint of there are discussions, or at least the desire to just leave the primer through some of the maintenance processes and not remove that, just for savings in process time and efficiencies.
So, if we're talking about the robot, we've got to talk about Zyvec. Can you tell us about Zyvec and who are they, and more on tell us about their big move to San Antonio?
Sure. So Zyvec is a company that's been developing robotic technologies for the aerospace industry. They have a broader vision than aerospace, as the technologies that they're working on developing are applicable outside of aerospace as well.
When did you know you had something game changing with this technology?
So we first knew we had something special when we were completing an internal research and development project back in the 2010, 2011 timeframe. It was at that point where we were completing the build of a different type of a large scale robot. We worked to integrate some laser process test solution that we wanted to try out and just check for viability. The testing went better than we expected. The strip rates were high. The process control worked as planned. And at that point, we had not seen anything else faster or more controllable on the market from our surveying. And we felt like it was something that would gain the attention of the aerospace industry, and it did.
So, robotics in general seem to be more prevalent these days. Are we getting closer to that futuristic picture of a robot in every home helping us in our daily lives?
Sure, absolutely we are. Certainly there's a lot of work to do in this space, but you already think about things that are in our homes. It could be the robot that cleans the floor, or I know a lot of people are starting to get what we call telepresence robots, which is essentially like an iPad on wheels. So there are some cool robot solutions too coming in from the food side, where you've seen like maybe in recent news articles, like the robot kitchen, so to speak. Um, we also see that schools are offering a lot more opportunities for students to get involved with robotics at an early age. And I think all of those things coming together are building the path towards robots helping us more in our daily lives through innovation and focus on robotics as a tool for us.
So, on the flip side of that, there's always a flip side. There are people who maybe fear robots taking jobs and leaving people out of work. What is your response as somebody in the robotics industry developing this technology. What is your response when you hear that type of reaction toward robotics?
Sure. It's a question that I get asked a fair amount, and I know it's a fear of many people. Um, so I think the answer is you rest assured that robots, they will take over a range of jobs. And I think, in the near term, they're going to mostly focus on what we call the dirty, dull, and dangerous jobs. Um, and we've seen from history, too, that the human race will continue to innovate no matter what. We see examples of productivity improvements throughout history. I think one of the classic examples is agriculture. You look at the number of people who used to be employed in agriculture before the invention of the tractor. It was a large portion of our population. But those jobs are mostly gone, and there's other new and different jobs that have replaced them. So I actually love the idea that robots, if you will, give humans more time to innovate and create new opportunities and new jobs. There's still a lot of work to do in innovation around robotics. So it'll take a long time before we can see them taking on the full range of skills that we do as humans on a daily basis. But I would also encourage people to study up on this topic themselves. And I mentioned that because I think if you do some deeper dives, you'll find that increases in productivity don't always track well with unemployment. So what does that mean? I think it really means that productivity improvements are not necessarily correlated with job creation or job loss. But what we see is when we innovate in robotics and automation, we see more opportunities for things like a boost in regional manufacturing opportunities in more developed countries. I think we see people creating solutions that are going to free up humans to do the things that we're really good at, where we're creating the world of tomorrow and we're creating jobs of tomorrow.
Yeah, that is an enlightening perspective. And I think it's important to say it again, that for now or, in the immediate future, you can see the robots taking over the dangerous and the dirty jobs, the things that you probably want to move people away from anyway. So,
Right.
yeah, really interesting. And that's a great perspective. So, I do want to move on to the award. The reason we're doing this episode, it's really, as I mentioned at the top, known as the Oscars of Innovation, the R&D 100 Award, a huge award in research and development. So, how does it feel to be recognized with the 2020 R&D 100 Award for you and your team?
This is a really big deal for us, for Southwest Research and our team of roboticists. COVID-19 concerns has certainly made it difficult for us to appropriately celebrate, but we look forward to when we can all get back together and have a big party around this. And I'm really proud of the team. There's so many who participated in this program. I would love to name each of them, but I will in the end. I just want listeners to know that it's truly a multidisciplinary effort. Each one of the core team leads and the staff that worked on this program are the recipients of this award.
Again, it's a highly competitive award. So it really is something to be proud of. So congratulations to you and your team.
You mentioned also that there's been over 115 Southwest Research employees working on this program at various times, some playing minor roles and other larger roles. I also want to say that this extends more broadly than the Southwest Research team. So there's also the Zyvec leadership. There's a host of suppliers that they have worked with as well. And I think they all share in this award as well, as Zyvec is our co-applicant. And also, as with any new innovation, there's a ton of talent and work that goes into making something like this award worthy. And again, I just thank each of our team members who contributed.
I know you have many robotics projects in the works, and now you are writing about them, which is neat. We all can kind of get an insight on what's happening with robotics at Southwest Research Institute. Can you tell us a little bit about your new blog?
Yeah, sure. We got together recently and started talking about how there's so many things that we work on, that we innovate around, from our internal research and development program at Southwest Research to things that we can share that are in the open space. And we wanted to find a way to share more information with our potential customers, but as well as the public. So we started a blog, and you can find that at robotblog.swri.org. We've started out with a little bit of historical information, showcasing some of the projects that we had early on. And then what we'll do is continue to push or publish things that are more of our latest and greatest things that we're doing in the field of robotics.
Robotblog.swri.org. Awesome. I think we all need to check that out. So to close today, what is the takeaway today? What would you like our listeners to remember about the laser coating removal robot or robotics in general?
So that's a great question. I think at the end of the day, I would encourage people to set sights beyond the here and now and beyond what robots do for us currently, and look towards the future of where robots can complement humans and the work that we have to do. And there's still a lot of work to do in putting robots into positions where we can employ them in highly repetitive jobs in dangerous areas where robots are just better suited. And then that frees us up to work on things where we can innovate. We can extend robots to new places where they've never been before. So that's what I would encourage people to think about: is what are the range of possibilities? If we can dream it, we will be able to do it.
Great advice. Look toward the future. There are so many possibilities with robots, and we've enjoyed learning about the laser coating removal robot today, really making a difference in the aircraft industry, making things safer. It's more environmentally friendly, just an all-around amazing technology that was recognized with the R&D 100 award. So again, congratulations to you and your team on that big award, the R&D 100 award for 2020. And thanks for being here, Paul.
Thank you.
And we continue with SPARTA, the System Performance and Real-Time Analysis Software System that is protecting fighter jet crews. SPARTA was also recognized with a 2020 R&D 100 award. SwRI engineer Finley Hicks is here with more. Hi, Finley.
Hi, Lisa.
Thanks for being here today. And I want to start with the overview of this system. What is SPARTA and what does it do?
Well, SPARTA is basically, it's an advanced test and measurement system specifically designed for testing electronic attack systems. An electronic attack system, or I may just call it EA, is basically a jammer system that uses RF transmissions to protect things like military fighter jets from being detected by enemy radars. So in order to verify that one of these jammer systems is working correctly, we need to be able to measure a bunch of different jamming and modulation characteristics. All existing test equipment that I've ever seen can only measure a fairly small percentage of these critical parameters. So we built SPARTA to specifically target all the things that can't be measured by other systems today.
What is a jammer system?
Well, a jammer system is basically a collection of like electronic boxes that are attached to typically an aircraft, like say an F-15, or it may be internal to an aircraft. But the purpose is to emit RF signals that will confuse enemy radar, so that when a radar tries to track a jammer system, it gets confused and it's unable to do it. Therefore, it can't shoot missiles at it, shoot the plane down.
Okay, so those jammer systems protect our fighter jet crews.
Correct, yes.
Okay, so SPARTA is a complement to those systems.
Yeah, I mean, SPARTA doesn't actually fly on aircraft, but those boxes I was talking about, those jammer systems, SPARTA tests those systems to make sure they're emitting exactly what they're supposed to emit. Because basically, if a jammer system does exactly what it's supposed to do, it can spoof or confuse, like I said, the radar. But if one of its parameters is off by a little bit, is incorrect in some way, then the radar operator, at least an experienced operator, will be able to tell the difference between jamming and the actual aircraft. It's very difficult at times to measure exactly what's coming out of these systems. It can look close with some of the test equipment we have today, but you don't know it's right or wrong until you actually go up against the system. And some radar systems we don't have exploited. So we may not have the opportunity until we actually get in, say, a war environment to go up against those systems. So you need a SPARTA to be able to tell you that your system is doing exactly what it's designed to do.
And why is a test system like SPARTA important?
Well, these jammer systems I'm talking about protect some of our military's most valuable assets and people. And the more capable or the more exact these systems are, the more effective they'll be at their purpose. It's the job of a test system like SPARTA to ensure that jammers do exactly what they're supposed to do. Like I was talking about before, jammers they spoof enemy radar, they confuse them, they can do some really cool things. They can make an aircraft look like it's going faster than it actually is, or maybe going in a different direction. They can also make it look like there's hundreds of like an F-15 instead of just one. So as you can imagine, if they're really effective at doing that, then a radar operator won't have a clue where to shoot a missile. But if they're not effective and the radar operator can tell the difference, then that's disaster for our crew.
So highly important to get
Yeah.
this right.
Yeah, it's Sparta's
so
job
this-
to make sure that happens, that doesn't happen, and it's right. The jammer system's right.
Yeah. So this all falls under the umbrella of electronic warfare. What is electronic warfare?
In simplest terms, electronic warfare, or we often just say EW, it's just a constant battle to control the RF spectrum. Good examples of EW are the radar versus jammer system that I was just talking about. The radar does its best to track the aircraft, say the F-15, and the jammer on that aircraft produces what we typically call electronic countermeasures to either hide or the aircraft or confuse the radar in some way. Then the radar can generate what they call countermeasures to confuse the jammer system, and this kind of goes back and forth, kind of like a sparring match in boxing. And it's just a combination of these events that we call electronic warfare.
Really cool. Okay, so I'm learning right along with you. So, because we think of warfare and you think of bombs and you think of just troops fighting each other. You don't think of this kind of invisible war going on between radar and these jammer systems, and that's really neat to be a part of that. So, what are electric countermeasure systems? I know that's a buzzword also that has been tossed around.
Yeah, so electronic countermeasures or ECM systems kind of goes by a lot of names. ECM or electronic attack, EA, those are synonyms basically. But I just typically just say jammer systems. I mean, that's the easiest way to say it, because visually that's what it's doing. It's producing jamming. And again, these are just electronic boxes of some kind that attach together inside or outside an airplane that help to protect it against enemy radar.
Okay, so the electronic countermeasure system is just that jammer system we've been discussing that SPARTA is backing up and testing to make sure that it's working thoroughly.
Yes.
What sets SPARTA apart from similar systems?
Well, it's basically its capability. There are a lot of similar systems. SPARTA measures important jammer characteristics that most of these similar systems can't measure at all, or certainly can't measure accurately. Existing test systems are typically pretty good. They're actually pretty good at measuring simple test scenarios. A simple scenario might be a single jammer false target in response to a single radar beam. However, this isn't even close to real world scenarios. In the real world, jammer systems generate constantly changing complex countermeasures. And a typical spectrum won't just have one radar signal in it. It typically will have tens or even hundreds of radars and lots of other signals, such as cell phones, that these jammer systems have to filter out. So SPARTA addresses all these shortcomings of similar systems in that it measures jammer parameters that other systems can't, and it can make these measurements in real-world test scenarios that may include up to millions of pulses per second.
Is SPARTA already in use by our military?
Yeah, we started SPARTA development, I don't know, maybe 4 or 5 years ago. And it was an IR for years as we went through
And that's
development.
internal research
Yeah,
project.
yes, an internal research project. And then a year to 2 years ago, we started marketing it to these systems on F-15s, F-16s, C-130s, and a lot of other planes you may have heard of. And they started using it very recently. C-130 was our first customer. The F-15 is now a customer of ours, and it's starting to feel some momentum behind it now that we've got it out there in the world, and they're seeing how much value it adds to testing. So we're real optimistic about where we're going, what path we're going, and the successes in the future.
Yeah, what kind of feedback are you getting from your current clients?
Oh, so far all positive. I mean, like I said, the C-130 was our first customer. They've been a repeat customer for the last year plus, which is great. It's great if they come back because that means you're adding value. Our F-15 customer, they're building a new internal jammer system, and SPARTA is kind of a central piece of their test plan to ensure this system does what it's supposed to do. So lots of positive feedback there. And that's just scratching the surface. There's tons of other systems out there. We think the F-16 folks are going to come on board in this next year. The A-10 folks, lots of other aircraft. There's other branches of the military, the Navy and the Army all have their own jammer systems. So we hope it's something that's going to steamroll into, large efforts every year. But so far, yes, everything's been positive, and we certainly hope to continue that.
So let's take it back to the beginning. How do you identify this as a need, and how was SPARTA developed?
So in the process of testing these electronic countermeasure systems in our field site, I tested them for about 10 years, and I always felt like I was doing it with one hand tied behind my back, without the right tools. So we kind of collected all the information that we really needed to test these systems effectively. And we went to Walt Downing and said, can we get an IR, an internal research project, to generate a system that will do all the things we need to do to be effective? So basically, it came out of experience. Our experience told us we needed something better, and now we have that.
So at SwRI, we often say our research and development benefits humankind. How is this a significant technology for all of us?
You're right. In the time I've been at SwRI, I've seen that our R&D programs can help advance knowledge and understanding in a ton of different ways. I've recently even seen several articles about ways we're impacting COVID-19 research. In the case of SPARTA, my hope is that SwRI R&D is playing an important role in protecting American lives in military aircraft. I personally sleep a little better at night knowing that our electronic warfare technology is keeping pace with the world, and SPARTA in its own little way is playing a key role to ensure that.
Yeah, how do you feel being part of this team? I'm sure it's a lot to be proud of, and you've seen it from the ground up. So is it a big source of pride for you?
It is. I mean, it always has been. Building something new. It's exciting. It's a lot of fun. It's why I enjoy working at SwRI. And winning an R&D 100 award, since they really only give 100 of these out a year, and it's global. I mean, it's a pretty exclusive company, and the entire team certainly feels honored and proud to be a part of the SPARTA team that earned it.
Definitely, and I'm glad you brought up the award because that was my next question, and we do want to talk about it because it is a big deal, and everyone we win is special and means a lot for not only the team that wins it and not only the technology, but for the entire institute. So, what does the award represent for you and your team?
Well, for the team, I hope it's validation of all their hard work. The team was made up of myself, Marcus Nugent, Jared Holcomb, Alex Davis, and quite a few other engineers that worked from time to time, side by side, to make SPARTA what it is today. You know, it takes a lot of work to build something from scratch. And this award feels like kind of the bookend for that development phase. And also, hopefully, it's a springboard to the next chapter of SPARTA.
So it's the big payoff in a way for your
Feels
hard
like
work.
it. And you don't often get that at the end of a lot of hard work. You may get a attaboy from a customer or something like that. That's great. But this kind of recognition, that was unexpected and really exciting.
So now I'm curious, what is the next chapter for SPARTA? What do you envision coming next?
Well, like I said, we've just really started scratching the surface for its purpose, to test these systems. We have a couple of customers. We hope that what comes next is that we have great feedback and additional customers, and we hire a bunch of engineers to learn to use SPARTA and to, you know, use it for what's intended. It'll help them to learn about electronic warfare, electronic countermeasures, how these systems work while they're actually testing real systems. It's really cool to be able to test the cutting edge systems. So right now, I mean, because SPARTA is so advanced, they're targeting it for the next generation systems, the systems that are just coming out. And therefore, we get to see some of the really cool techniques that are being generated. And you know, I kind of grew up on some of the legacy systems at SwRI, and seeing these next generation systems is a lot of fun.
So it's probably hard to name just one, but what was, or what would you say was the biggest breakthrough moment while developing this technology? When did you know you had something big?
Well, from a technical standpoint, you're right. It's really hard to pick a breakthrough moment. I mean, we had lots of aha moments in the lab where we learned how to measure something new. I always knew we had something big in terms of hitting a hole in the market. You know, whenever there's a need, it's because we worked, you know, these kind of systems for years. So whenever there's a need and you work the system, you see it, you see the hole yourself, you realize, man, if this existed, it would make our ability to build these countermeasure systems much easier and more effective. You just hope that customers will see it the same way you do. They may not value testing as much as I do, say, for example. So I guess the single biggest breakthrough, at least for me, was convincing that first customer that they needed SPARTA, and seeing that customer, you know, put us on contract, use SPARTA, and be very impressed by it. Enough so that they're coming back to us again and again, and we're even adding new customers. So it's not usually the marketing moment that is the moment that is the big breakthrough, because as engineers, we're like technical, but really that was the big breakthrough for me, is getting those customers in line.
But I can understand that because it was the moment when someone outside of your team, outside of the institute, saw what you had been seeing this whole time. So in a way, it's validation, and I can understand where that's a huge moment where you know that this technology you've been working on for so long is going to be used in the real world. So that's got to feel good.
Yeah, it certainly did.
So, to close today, what would you like our listeners to remember about SPARTA?
If there are any military folks listening, I'd really like them to know that SPARTA exists, and we'd love the opportunity to show them what it can do and how it can help them build a better system. SPARTA's always represented to me ways that we can use R&D funds to give us the freedom to create something new and exciting. SwRI's focus on R&D and its internal research are pretty much the main reasons I chose to work here over 20 years ago.
And this has really been eye-opening for me, just to learn about this type of warfare that's happening, like I said, like we talked about, electronically. And so this is an important system. It's been really interesting learning about SPARTA today. And I just want to say one last congratulations on the R&D 100 award to you and your entire team. And thanks for joining us today, Finley.
I appreciate it, Lisa, and I really enjoyed talking to you.
The Fall 2020 Technology Today magazine is out with more on our R&D 100 award winners. Check it out at technologytoday.swri.org. This month marks our second anniversary. Thank you to our loyal listeners who have been along on our learning journey for 2 years now. Don't forget, share our podcast and subscribe on your favorite podcast platform.